Welcome to my talk on user-centered AI at ICME 2020. I'm Susanne Boll. I'm leading the research group of Media Informatics and Multimedia Systems at the University of Oldenburg in Germany. I'm a researcher in the field in multimedia since over 20 years now, and I very well remember that I attended this conference already as a PhD student in the year 1999. I still have the two big and heavy books from the proceedings in my shelf, and they contain very exciting articles from the early years. So I'm happy to be here over 20 years later, and I'm also happy to speak to you about user-centered AI today. So let me just share a little bit more of my research background before we come to the core topic of today. In the field of multimedia, from the very beginning, I was working in the field of understanding personal media collections, on creating multimedia stories from content and creating interactive media experiences. Also interested by interaction and interactive system, I was moving into human-computer interaction, and I created multimodal user interfaces, immersive and multisensory experiences in ubiquitous and pervasive environments. So over the years, my research passion has shaped, and I would say the overarching passion that I have is designing interactive systems for a respectful and beneficial cooperations of human and intelligent technology in our common digital future. And AI will play an important role in this. I have chosen this background image from a book that I recently read and very much like. It's a report by the German Advisory Council on Global Change, and it's called Towards Our Common Digital Future. Already the first 50 pages give you a wonderful inspirational view of the role of digitization sort of in our decades to come. And there's a huge digital transformation that we can expect, and now is the time, and it is on us that we build this common digital future. And if it's well designed, if it's well applied, it can be a fundamental pillar in our society, and the digitization could be grounded on human rights, grounded on human dignity, on participation, and it can be a transformation on our sustainable future. So now let's come back to the question of where user-centered AI matters. So one of the core areas I am working in is safety-critical interaction. And this is exactly the point where it's so important that the interaction between the user and the AI is well designed. In intensive care units or in medical applications in general, AI will support treatment decisions. AI will help us drive automated cars. AI promises to optimize production lines. And it also will enter, for example, maritime navigation to support a safe navigation on our high seas. In all these areas, the human factors, are so important, and the human will still be for many years highly involved into these processes and application domains. So it's highly important that we involve the user right from the start. The human partner needs to be in the loop from the very early beginning, not only in its usage but from design. And this is why sort of research is so necessary in this field. But let's go a little bit back and ask ourselves why specifically with the advent of application of deep neural networks and applying them in many different areas, we started the need to explain. So why do we need to explain AI in the first place? So I'm sure you have seen illustrations like this before that are showing how a neural network is constructed, and it illustrates how it works. So neural networks have been on the table already when I was an undergrad student. And I recently again went back to my bookshelf and I found this textbook on the theory of neural networks, a systematic introduction, in the beginning of the 90s. And also, it was at that time not doable in the sense of the computational power that we have today, the data sets, and also the many tools we have around. So now deep learning has become mainstream, and with the availability of the necessarily infrastructure for this, almost everybody can use it. But even though you see them a lot, the question still is how they are created, and this is why we needed or started to need to think about explaining it. So all of these networks are learning from examples, and after the learning process, the knowledge is hidden in the network. And if we look at this a little bit more deeper, we moved from programming to learning. So in a program, I could ask and see in some lines of code if it has 4 legs and 2 pointed ears, if it has 2 eyes, nose, patterned fur, and a tail. Probably it's a cat. But in a deep neural network, this information and the knowledge is encoded in the network. And this was the biggest difference. And this was very quickly leading to the questions, how do we know what the network has encoded? How do we involve the user who has created the net and sort of explain if that what we have trained is exactly what we wanted to train? So in a very interesting work, and I'm showing here a prominent example from the GradCam algorithm on visual explanations for deep neural networks, we can ask, why did the network think this image contained an African elephant? And where is the African elephant located in the picture? So we are creating tools on making the human understand what areas, what elements of the image made or is driving the decision if this is classified as an African elephant. But now the next level is sort of, if the AI is so widespread, don't we also need to explain it to everyone? So what we started doing is to explain AI for beginners. So as everybody should be able to have an understanding of what a deep neural network, of a convolutional neural network is, the question is, how do I understand this? There's a lot of video tutorials out there and so on, but you could also try it out yourself. But you would have to have a reasonably good technical knowledge, ability to download libraries and data sets. So it's kind of an effort to get there. And the question for us was, can we explain AI for beginners? Can we design a convolutional network without actually all this implementation, downloading and running effort, but just as a web-based application? But you can still get your hands on, you can still select the data set, and you still see what the different construction of a convolutional neural does to your results. So we developed this application, which is called Simplify AI, and we called it like demystifying deep learning. And we created a tool in which you can walk through all of the steps and really get your own data and your parameters running. So here I created a network that can tell apples from pears. And you see, as the icons indicated, the different steps in which you decide the training set, in which you design the number of iterations, in which you construct your levels of the convolutional neural network. And you can also see the output, sort of how does it classify where are the false positive and where are the false negatives. And you can reiterate to sort of get a better understanding of the different effects of your parameterizing this neural network. So starting out from the question that learning, specifically deep learning, has risen many questions on explaining it, I still would ask the question, is actually explaining enough? So the question that we explain AI to someone is probably not solving the question of us interacting in an AI-driven environment. In a recent workshop on the legal and ethical issues on AI and multimedia, we were discussing several factors that are of course related and important in the context of AI. So naturally there is this discussion about fairness, accountability and transparency. Also the role of privacy and legality. But in this talk, I would even make a stronger perspective on the user. So how is the human involved into the design and the decision of AIs in our day-to-day world. And this is the reason why this is so necessary. AI will be there for us everywhere and anytime. It will be there when I learn, when I collaborate with my team, when the food is cultivated, when we live in smart cities, when we buy and when we work, and probably many other areas also. And on this perspective, so that it's going to be everywhere for you, we need to ask ourselves the question of what factor of the human needs to be involved into the design, and what are the human needs that should enter the design and implementation of AI-supported systems. So let me walk you through a few aspects that I would like to address, the elements that I think we should be really much paying attention to. So the first question is, if we are at this moment, and probably also potentially in the future, are we still in control? As the AI elements are entering manifold applications, the question is, can we still actually decide what we use? So far we only have choices to like an install or don't install. It's pretty binary. But what about the question if I want to use only a little bit of the AI functionality but not all of it? Can I just sort of say the AI is used for a certain service but not for another one? Can I use the service only in this application but not in another one? So it is very important that the users have choices. They should be in control. It should be easy for them to control their choices at any and at different points of in time. And I think this is one of the aspects we should be really looking in user-centered AI, that the human is the person who controls, and not any kind of an application or a company or a device should be controlling on how much and like on or off AI should be used, but it should be me who decides it. And if we are moving into a domain where everything is just around us, I think there's a few tools that I just showed here on this slide. The question is, if I am exposed to AI, can I actually consent or not? Do I agree or not? So looking at the GDPR Article 2020, consumers have a right to become involved when the systems are based on solely automated processing. But if I'm in my smart home, in my work environment, in my office space, in a medical environment, how do I say yes or not? So as one example I'm showing you here, we have been exploring actually gestures to opt in or opt out into a smart and intelligent camera system. And we found that with elicitation and also with evaluation, we were able to show that there is a potential for a vocabulary to opt in or out in certain situations. Even though that does not hold for all other applications, we definitely need to look into different application domains and see what is the way in a pervasive and ubiquitous computing environment that I can actually agree or not agree to AI and make it user-centric, so I am in control also if the environment doesn't have buttons and pins and checkboxes. This is highly important, and it's also fully supporting the GDPR in a ubiquitous environment. Another assumption that we see sometimes with AI is that an artificial intelligence system is designed to make, let's say, informed and optimal decisions. But I think it's not very difficult to find examples where AI finds its limitations. So at this point in the situations we find ourselves, the AI might sort of need some additional information, or we might sort of cooperate or even negotiate with such a system. You see an example here where a pedestrian in our social automated vehicle project will be discussing with their vehicle on who actually should go first. So one element, of course, is that the car should always wait and the pedestrian can cross. But in our future cooperative way, we should definitely think of negotiating. Like in real life, you could say to someone else, oh wow, why don't you go first? So is that something we would still to have with artificial intelligence? So we will need to communicate sort of the information and the decisions the AI wants to make and the human wants to aid, and potentially even negotiate on who goes first. And this is something we are just seeing as first research steps. But for me, it's kind of important that this negotiation with an AI is an inner part of our designs. And the element that comes in addition to that is the question of when is this negotiation and discussion happening? So in many cases, I think automated driving is a very prominent case of that. The explanations and the interactions need to be instantaneous. It needs to be now. So there's not much time on like a 10-hour debate on what we're going to do. So in many areas, this communication, this conversation between the human and an AI-supported system will have a very narrow time frame, and we need to be designing for that. For example, we worked on takeovers in after automated driving scenes in which the takeover gives some additional information that the human can better understand of what to do now and what comes next. And in a more complex scenario we discussed in a workshop at Auto UI last year on how this would actually work in much more complex day-to-day pedestrian crossing situations. So AI and explaining AI and negotiating and discussing with AI not only has the role of sort of how do we understand each other, but it might in very safety critical applications come with the question that we only have a short time frame for it. Another element that is I am really caring about very much is what AI does to our work and labor. So the question is, if we are designing AI today, we are often highly excited what this wonderful system can do. For example, if you have a robotic system, there's AI involved, and this robotic system can now do something. But we need to design it in a way that it's not only integrated somehow, put there in some work context, but it's actually cherishing human work. Look at this example from care. In this case, in our innovation center in care, my colleague is actually developing a robotic arm that is supporting the medical or the care staff. So the individual person really wants to care and really needs to look after a wound of the individual person. But lifting and keeping an individual up is very heavy. So it is also a lot of caretakers have problems with their back because lifting up patients every day and regularly is a very heavy task. So here you see a synergy of a maybe AI supported system and integrated into a workflow. But we have to very careful that whatever system we integrate into that is something that is supporting. It is not marginalizing or it is not devaluating human work, but it is cherishing the work. It's just taking these parts that the human identifies as highly necessary to be relieved from, and he or she wants to concentrate on that part that the human can actually do better and the sort of can also for which he or she was trained to do so. I think this is a very sort of a field where we need to really very well balance out what the system does and what it should do and how this affects our daily work in a way that also in the future our work and our human work will be cherished, and we want to using the best out of what we can do and complemented by those that are well integrated, that are AI supported or automated supported. So I think that's a very interesting thing, and we see a lot of this discussion in our research center on innovation in care. As we see in this example, we have AI also and often manifested in something, in anything that does it for us. It can be a car, but it can also be a voice assistant. So in a workshop that we run at Kai, there was a very interesting phrase that came up that was questioning, so should you say thank you to Alexa? So whenever AI is more or less integrated, embedded into something that has a physical appearance, the question is, what is my relation to that? Is the AI just an extension of myself, or is it something else? Does it actually need respect? This was the very interesting discussion point here. So when we think of an AI that is embedded into devices, entities, objects around us, we need to discuss how are we designing these in relation to us. What are the roles this other thing has, and what are my communication strategies between? So there might be different options, but we need to deeply look into that and understand how otherness needs otherwhere, which is the title of a workshop in which we will be discussing this with colleagues at Nordica this year. And it's going to be very interesting in this tension between the other artifact and me as an individual, and how we are designing for an interaction and a relation of the two. If you have a very cool AI-driven device, but nobody likes it, so what do you do? So we developed an AI-supported smart glass, which we called Privacy. So what you see here is a novel interaction device. It's head-mounted, and it captures a first-person video. But as you can see, it differs from existing smart glasses technology, and it can actually open and close its lid. So we built this as a response to create a privacy-aware smart glasses that clearly indicates if I am recording or not with a very strong visual affordance. And we designed it such that like a personal conversation that I'm just having with you would be easily detected, and then it closes, and then it opens again if I'm going out into a wider space, and the potentially privacy-aware situation goes away. So whenever we are designing AI-based systems, we need to design them for social acceptability. If it's going to be the robotic arm in care, if it's going to be a smart glasses that are capturing you on some AI-driven selection process, make sure that you are designing for social acceptability. It's not going to be implemented and it's not going to be accepted in real life if we forget to design this into our systems. And we just recently published a survey on the different existing approaches in human-computer interaction on how to design and with methods to design social acceptability into interactive systems. And going one step further, it's not only me and some device, some system. So this AI is not only affecting a relation of two, maybe a user and a system, but it's also affecting bystanders and other people who are passers-by. So if we look at the larger number of people who are affected, which could be my partner or my colleague, it could be the neighbors, it could be my work colleagues, it could be my entire institution. What is highly important is that if we're designing AI that affects a lot of people, we should also include them. So designing AI for us should not happen without us. And this is an important message that I have, saying that we need to really see the larger image of who is affected and involve these individuals into the design process. So AI is actually a part of a social technical ecosystem. So it's not only affecting the data processing and optimizing of functions and systems and adapting the user interface. No, it may change an entire social technical ecosystem and its implicit knowledge and communication traditions. So here's like two examples from colleagues from Osnabrück, from the PACE research group, and they are actually observing a change in a company which has a mobility service. So different drivers were picking their different routes and tours previously in an analog fashion. And now they introduced an intelligent scheduling algorithm. And they were kind of surprised that this new intelligent system did not get a high acceptability. But what they weren't aware of is that this digital systems has changed so many of the social and communication practices, like chatting and negotiating tours, getting your preferred tour, having more breaks for chit-chats, meeting yourself when this cold process of picking tours and so on is going on, that they fully underestimated that this created a bad company climate, and that sort of the necessarily social interaction between the people working in that company was lacking. So we really have to consider AI as a part of a social technical system, and also look into traditions, communications, and implicit knowledge when introducing it into some work or private context. And coming closer to the end and asking us who actually is responsible if we are introducing AI, and if AI is making an error, I would like to make also a strong comment on the role of the designers of AI. So today, in many safety relevant areas, we see AI is entering. So it's making decisions, it's making recommendations, it might make even helpful actions for us, thinking and hoping that this is kind of for the better for your safety of you. However, we see elements and places and situations when it gets critical, then at some point the AI cannot decide, and then it's kind of offloading the responsibility of deciding to the individual. So in some extreme cases, then we don't have a situation in which the AI can make any kind of a decision, and then leaves it to you, the human, partly even in a short time frame, to understand and react. And then we see this popular headlines say, oh, human error is like responsible for 85% of all ship accidents. But what we really need here is a paradigm shift, that we don't leave the error to the human, but we are designing it out. And this is even stronger with AI. So we need to have a paradigm shift that avoids human errors already at the very early design time. And this is what we are discussing at a Kai workshop this year, which is bringing researchers from safety critical domains together to understand how can we designing out human error at a very early time, and don't leave it at the end to the human. So, concluding, I would like to say that today we are observing, anticipating the effects of AI in many research areas. We aim to make the human kind of feel more comfortable with AI. But tomorrow, we have to look that the user-centered AI is implemented to give users control, to give users the option of opt-in and opt-out, to give them negotiation and discussion with AI, to have them define their relation to AI, designing out human error, and sort of view the entire ecosystem. So in my future vision, I see that we need to be designing AI for a respectful and beneficial cooperation of humans and intelligent technology in our common digital future.